How's it going, everybody? And welcome to another installment of Tech Support Thursday. I believe this is ticket 49 when I went back through to look where we sit. I'm going to do my best to try to do a regular installment of this. So sometimes the questions come in waves, sometimes the questions, there's nothing for weeks. So, and I want to get back into the Whiteboard Wednesday, but I don't know if I would go live, because right now my priority is to go through the SP CCIE content and get that knocked out, and then start recording content on it and work on the workbook that will accompany it. So I'm still trying to figure out the logistics on that. I do have two servers that I can get this working on. So both of my Dell servers that I can use. One I've got for learning the technologies and stuff like that, or learning new features or capabilities, or going back over stuff that I haven't touched in a really long time to bring myself back up to speed as to what they're actually doing. And then newer technologies that I haven't spent as much time on, or a different way of doing them than what I'm already accustomed to. That's a lot of what it is. Like, I just spent a couple of days going over EVPN and how that works, and a lot of it is very similar from VXLAN to MPLS based EVPN. So a lot of the same concepts apply with the capabilities and things like that. So for the most part, it's not that much of a stretch for me to go learn the new way of doing it. So my plan right now is to build out a single service provider that will have multiple customers attached to it with lots of customer edge devices. And the intent would be to go through and test out all the different things that you might get tested on. So my primary focus will be a single service provider for MPLS, traffic engineering, layer 3, layer 2, multicast VPN, QoS, segment routing, traffic engineering, and then SRv6. Those are the big things that we're going to test on. Now, I do realize that if you look at the SP core and SP routing, implementing routing, there's a heavy piece of that is focused on routing, IGP, BGP, multicast, those type of things that are non-MPLS. The routing and switch, the lab exam for CCIE is not as focused on straight routing as it is MPLS, RSVP, TE, SRTE, SRv6, still labeling, right? There's still an emphasis on the routing component. So what I'm planning on doing, and it's still hit or miss in exactly how I'm going to do it, what I'm thinking about doing is a heavy emphasis in the beginning on anything labeled, right? MPLS, TE, SR, SRTE, SRv6, those things. And then I have another section that is specifically focused on routing, but in a much smaller capacity. Not a very large topology of like 30 or 40 routers that is just not feasible for a lot of people to lab up. A much smaller concentration, 10, 15 if I had to guess, that are going to be focusing on more advanced routing capabilities. Because of the fact that I'm not going to be doing a CCNP Service Provider video series, the workbook for CCNP Service Provider will lay some of the groundwork, and then the workbook I'm working on for CCIE, it will have a condensed version of it. It'll be a little bit bigger than CCNP because there's obviously some things in CCIE that aren't covered in NP that I would need to go over. But at the end of the day, these are the things that I'm thinking about, because I know from sitting for SPv4, there was no straight IP routing, right? There was no just plain internet BGP with next top self and stuff like that. There was no non-labeled anything in the lab exam. So everything tied back to labeling. So my guess is, and from what I gathered from talking to people that have taken version 5, that there's not going to be a dedicated section for just internet routing, because internet routing can be deployed on top of MPLS. So it's just how it's done is a bit more unique in the capabilities and stuff like that. So it's one of those things where I won't say I'm struggling with it, but just figuring out how I do that, because my goal is to have a topology that isn't so big that it's just egregious, because I've come up with some like really over the top designs to demonstrate the different technologies in like a one big super lab, and it's just not feasible for the average person to follow along. It's just not, unless you're running Eve yourself. Most people, I'd say it's probably split down the middle. I'd say half the people that follow my content or are out there studying use CML, which has a 20 node limit, and the other half are using probably a combination of Eve or GNS3 or something else that I'm not familiar with, or maybe they're running virtual machines inside of ESXi, or you're using container labs. There's a number of other mechanisms or lab platforms out there that you could use. So part of me being the instructor and labbing this stuff out to teach you guys, well, teaching is probably the wrong term, just to share what I've gone through and do a bunch of demonstrations on the technology. You pick out of it what you want to watch. If you don't care about multicast VPN because you don't touch it and you don't want to learn about it, cool, you can skip that section and dive into, I don't know, SRTE or something like that. So the bottom line here is I'm trying to keep the labs that I want to build out and focus on specific to a smaller design so that you guys can build them out at home and they're doable, right? So that's the logic that I follow. So that's kind of the direction I'm thinking about going at. If that makes sense to you guys, let me know in the comments. That's the direction I really want this to kind of go, is let me know what you guys think, if I'm off base, or if you're like, don't try to cater to us, the student or the viewer. We want you to teach the technology so we can understand it and really grasp the concept. And if you have to go bigger to make it like stick and be have the impact that you think it needs to have in order for the content in the video and the technology to get discussed the way that it needs to be, then I could go either way, really. But I'm trying to be cognizant of the fact that there's a lot of people that watch my stuff that don't have the ability of building a really big lab and following along. I know I struggle when I'm first starting to learn something. If I can't lab it up and follow along, it's difficult for me to wrap my head around it. But the moment I take the diagram, I build it, and I follow along through the steps, and then the steps start to fall into place for me, things start to click, and I'm like, oh, okay, this makes sense now. But if I'm just trying to like follow along in the video, sometimes I put myself to sleep sometimes. So that's kind of where I'm going with that. So let me know what you guys think. But the goal that I have for the bulk of the stuff that I want to cover, single service provider out of the gate, and we cover all the different technologies. So we cover layer 2 VPN, layer 3 VPN, QoS, TE, multicast, segment routing, SRTE, SRv6, all that stuff. They're all of their individual sections, and we're starting fresh each time we walk into something. And then there's how do we integrate those different technologies at the same time? How do we overlay layer 3 and layer 2 VPN at the same time, or multicast VPN? And then how do you do QoS and traffic engineering and those type of things, and sort of layering them in so that they come together. And that's kind of where full-scale labs come into play. So when you've gone through the bulk of the technology, you're able to go through, and now the full-scale labs are, okay, now we've covered all of this. Now I'm going to take parts from each of this body of work, and we're going to build out a full-scale lab and get that to work. And then we're going to walk through the specifics of it. That's my game plan. So there's going to be a lot to go over, but that's the direction I would like to go to make this have the impact that I want it to have. So, with all that being said, and I'm at the 10-minute marker. I'm going to try to keep this relatively short. Try is the key word here. So, I wanted to cover a couple of questions that were posted from a few weeks ago and try to keep up with the Tech Support Thursday and knock these out slowly over the next few weeks. And then if you guys have additional questions, you can drop a comment and we can continue this process. So congrats on the CCIE decade anniversary. Appreciate that. Can you clarify what you mean by solve 2 fill scale labs per day? So those labs were pre-built labs with a walkthrough attached to them, and so the goal was to try to get you in the mindset of CCIE and the complexity of CCIE. Sometimes they were the labs were more complex than the lab. Other times they were not. I do not have them anymore. That was a long time ago. So I got rid of them after I passed. So there was really no need for me to keep on to something. It's the bulk of the lab now wouldn't even relate. So petition to prepare for the lab and attempt it again, definitely going for it. So this other question, I'm completely lost regarding when each of these should be used. May you please explain them? Address family, label DataCast, send label, and allocate label. All right, so pull up Paint here, and we'll quick whiteboard through these real quick. Let me go ahead and get out of the way. So the first one, we'll set up a really simple demo. So we've got PE1 here, we've got P1 here, we've got ASBR1 here, we've got ASBR2, we have P2, and we have PE2. And then these guys are all connected to each other like so. What will end up happening is this guy right here will be XR. Well, all this stuff will be XR. These are all XR routers. These are all XE routers. So what you would do, and let's pretend like per P1 and P2, well, for the sake of argument, let's do route reflector 1 and route reflector 2. These guys will connect like this. So what you'll do is in the core here, you'll run, let me draw this up here, you'll do IGP LDP here, and we'll say IGP LDP here. You'll also do multi-protocol BGP, so we'll just put MPB. Let's put BGP here. You'll do BGP here as well. So you'll get all that running. So normal layer 3 VPN operations, and then you'll have customer edge 1 attached to PE2, and then you'll have customer edge 2 attached to PE2. So the ASBRs will learn the customer edge routes, and well, sort of. So what will end up happening, and it's kind of a layered approach. So where this would come into play is what they refer to as MPLS L3 VPN that's a horrible N, enter AS option C. And the idea here is that this is probably one of the most scalable ways to build layer 3 VPN. And what ends up happening is the route reflector forms between the PEs and the ASBRs on both sides. You use IBGP labeled unicast, and that's where that labeled unicast comes into play here. That's done on the XR boxes. On the ASBR and the PE router, you can advertise their loopback addresses and the route reflector. That's more specifically the PE and the route reflector. That's really who you need to do this with. You take their loopback on these devices and you advertise them into IPv4 unicast. So on XR, you actually have two different flavors of IPv4 unicast. You have IPv4 unicast, and then you have LU, which is labeled unicast. So you run labeled unicast between your route reflector, your ASPR, and your PE routers. Your route reflector and your PE routers will advertise their loopbacks underneath IPv4 unicast, and then underneath there you'll use the command allocate label on the XR boxes. So once you do that, then the ASPRs through IPv4 labeled unicast will learn those those loopback addresses through this address family. Once you do that, then on the XE side of the house, you do the exact same thing. So the route reflector will form peerings with the ASPR and the PE routers through normal IBGP. So this will not be VPNv4. This will be straight IBGP. So you form IBGP, and then you would peering, and underneath the address family IPv4. So you do add IPv4. When you use the neighbor command with the whatever the address is for the IBGP peering, you would use the command send label. So you send label across the board, ASPRs, PE routers. That'll get you where you want to go. And then what you would do between the ASPR and between the ASPRs on this side here, you would use an LU peering in IPv4 unicast going this way, and then you would use under address family IPv4 on ASPR2 going towards ASPR1, you would use the command send label bidirectionally. So the traffic would go back and forth directionally. They would exchange labels with IPv4 unicast on XE and address family IPv4 labeled unicast in XR. When you do a show BGP IPv4 labeled unicast on XR, you would see those loopback addresses from this provider here for the PEs and the route reflectors being learned in IPv4 labeled unicast. Once you have that completely built, and the PE routers can see each other, and the route reflectors can see each other, you can do a trace route and a ping, and you get route reflector 1 can ping route reflector 2's address. What you then do between the route reflectors is you form a multi-hop eBGP peering of VPN v4 and v6 peering between the route reflectors. That's done, and then you form with all the PE routers from the route reflectors and their respective autonomous systems, you form VPN v4 and VPN v6 peerings from the route reflectors down to the PE routers. That will allow this customer edge 1 subnet, whatever the LAN segment that's hanging off here and getting advertised to PE1, that'll allow that to get propagated to this route reflector. That will then via VPN v4, VPN v6 advertised to this route reflector, and this route reflector will advertise that down to this PE router, and then that PE router will be able to advertise that down to CE2. CE2 will end up receiving that prefix, and then that allows the end-to-end VPN v4, VPN v6 peering or route advertisement to happen. Now there's one caveat with this, is on this peering you would have to go ahead and use the command next hop unchanged. So I'm just going to put NHU for short. Next hop unchanged, because if you don't do that, then the PE1 will see any routes learned from the other service provider originated from route reflector 2, because PE2 advertised to route reflector 2, route reflector 2 advertised to route reflector 1, route reflector 1 advertises to PE1. PE1 will see route reflector 2 as its next hop in the BGP table. Because it sees that, when it does the trace route end to end, the trace route will go PE1, PE1, ASPR1, ASPR2, P2, route reflector 2, and then route reflector 2 to P2, PE2, then to CE2. And so the path will look a little like this. So the path will take this, and then another path this way. So it'll be a 2-label stack, or 2 label switch paths. In order to fix that, you use next hop unchanged, and then the path is customer edge all the way across the board to here. It's one VPN label and a number of different transport labels and BGP labels allocated. So this is one of the few times you would actually see a 3-label stack without traffic engineering. So that's how that comes into play. So just to recap it, between the ASPRs, on the XR side, you would use labeled unicast and allocate label on those routers to allocate labels for the received routes. The PE routers would also do allocate label, and so would the route reflector. They do allocate label underneath the address family IPv4 unicast, but they would form labeled unicast IBGP peering inside the service provider, and then the ASPR to the XE ASPR. You still need to have some sort of underlay routing, and this is where IGP and LDP come into play, so that there's a transport label in the core. So you would see a combination of both BGP and LDP labels to get you through the SP backbone. Once you've done that, then you're in a good spot at that point, and then you have end-to-end reachability. So as long as that makes sense, that's really where this comes into play. And I will be demoing this out as we get into the capabilities of how other stuff comes into play, and as we get into the weeds, because like I mentioned, I'm planning on doing a single service provider out of the gate, and then I will expand that into multiple service providers, carrier supporting carrier, so on and so forth. But that'll be further on down the way when we get into layer 3 VPN, layer 2 VPN, multicast VPN, all that stuff that comes into play where there's multiple service providers. So hopefully that answers your question. That was a relatively easy one to knock out because of the what it is. I'm going to continue to work through these probably once every tech support Thursday, and we'll go from there. If you guys have any questions, comments, concerns, feedback, please drop a line down below, and I'll catch all of you guys in the next one.